What if our galaxy, the Milky Way, was hurtling toward a cosmic train wreck? Imagine billions of stars colliding in a violent dawn-sour sky would never look the same again. The Milky Way and Andromeda galaxies, two colossal spirals drifting through space, are on a collision course. But don't panic. Just yet their encounter is billions of years away. In this video, we'll dive deep into what would really happen if these two galactic giants collided. From star-shattering chaos to breathtaking cosmic fireworks, we'll explore the science, the potential dangers, and the mind-blowing transformations that could reshape our universe forever. Stick around, because what I'm about to show you will completely change how you look at the night sky. Our story starts 4 billion light-years away, or more accurately, right in our cosmic backyard. The Andromeda Galaxy, a massive spiral structure over 220,000 light-years wide, is slowly closing in on the Milky Way at roughly 110 kilometers per second. That's fast, but in cosmic terms, it's like two titans inching toward each other in slow motion. Both galaxies are swirling cities of stars, dust, and dark matter, each containing hundreds of billions of stars. But here's the first mind-bender. The vast distances between stars mean that individual stellar collisions are extremely unlikely. So, while it may look like a catastrophic smash, most stars will simply pass each other by. However, the gravitational forces will wreak havoc on the galactic structure itself. As Andromeda approaches, the Milky Way's disk will begin to warp and stretch. Imagine the gravitational tides, the same phenomenon that pulls at Earth's oceans, only magnified across tens of thousands of light. Stars that once orbited in predictable paths will be flung into chaotic trajectories. Star clusters may be ejected entirely, and new ones may form from the dense clouds of gas compressed by the gravitational collision. In fact, scientists predict that the initial encounter will trigger a spectacular a cosmic fireworks show where new stars ignite at rates hundreds of times faster than normal. The night sky, if viewed from a safe planet, would glow with millions of new, brilliant stars, more than any human has ever seen. At the hearts of both galaxies lie supermassive black holes, Sagittarius A*, in the Milky Way and a giant in Andromeda S-core. As the galaxies merge, these black holes are destined to spiral toward each other in a titanic gravitational ballet, eventually colliding in a release of energy so intense it could ripple across space-time as gravitational waves. This process will take millions of years, but it's the climax of the galactic merger. While the black hole's immense gravity might swallow nearby stars, they will likely leave planets like Earth mostly intact, though our solar system could be flung into a completely new orbit, or even ejected from the newly forming galaxy entirely. Imagine being a cosmic castaway drifting through intergalactic space, watching the new galaxy take shape from afar. As the merger continues, the once distinct spirals of the Milky Way and Andromeda will gradually lose their shape. Simulations show that they'll form a massive elliptical galaxy over billions of years, a giant, rounded structure composed of older stars, with younger stars formed during the collision sprinkled throughout. Gas clouds will collide violently, triggering shock waves that compress material and create brilliant nebulae. Star formation will spike, and the night sky could be littered with supernova explosions, black hole jets, and streams of stellar debris. If humanity were still around, stargazing would be like watching an epic cosmic symphony unfold in real time. While the galactic collision is cataclysmic on a grand scale, Earth's fate is relatively mundane. The odds of a direct collision with another star are negligible. The danger comes from gravitational perturbations. The solar system could be nudged into a new orbit around the combined galactic core, or, in a rare scenario, ejected entirely. Earth might drift through interstellar space for millions of years, a rogue planet illuminated only by nearby stars and the fading glow of the galactic merger. Yet, even in this chaos, life might persist. Our sun will continue its own life cycle, and perhaps future civilizations will witness the birth of a completely new galaxy, a legacy of the grand cosmic dance. But here's the challenge. Predicting the exact outcome is incredibly complex. Galaxies are made of dark matter, gas, dust, and stars, all interacting in unpredictable ways. Will our solar system survive in a relatively stable orbit? Will star formation reach unprecedented levels? Or will black hole activity dominate the scene? Scientists can simulate these events, but billions of years of cosmic evolution leave many questions unanswered. NASA and other astrophysicists use supercomputers to simulate the Milky Way Andromeda merger. These simulations reveal that the collision will likely occur in multiple stages, first past 2 to 3 billion years from now. Andromeda will pass through the Milky Way, triggering tidal distortions, new star formation, and possibly some galactic cannibalism. Second encounter. The galaxies swing back toward each other, colliding again, further mixing stars and gas. Final merger. Over another billion years, the cores of both galaxies will merge, forming a massive elliptical galaxy. Interestingly, these simulations suggest that, visually, the night sky would be dominated by spectacular arcs, glowing filaments, and streams of stars drawn into the merging cores. From a distance, the Milky Way Andromeda collision will be one of the most breathtaking events in the history of the universe. The merger will reshape the entire local group of galaxies. Smaller satellite galaxies may be absorbed or ejected. Star formation in Andromeda and the Milky Way will reach an all-time high, producing a generation of stars far more luminous than what we see today. And the black holes, when they finally collide, they'll emit gravitational waves detectable across billions of light, sending ripples through space-time itself. For scientists and astronomers, this event will be a treasure trove of insights. It will reveal the behavior of dark matter, the formation of elliptical galaxies, and the extreme dynamics of supermassive black holes. And for life in the universe, it has a dramatic reminder of how fragile planetary stability can be in the face of cosmic events. Imagine this. Billions of stars shifting in a slow, deadly dance. Nebulae erupt like fireworks. Black holes spiral together with gravitational forces so intense they warp spacetime itself. The Milky Way's spiral arms stretch, twist, and merge with Andromeda's, forming a luminous, chaotic web of stars. In this climactic phase, the universe is both violent and beautiful. Our night sky transforms into a spectacular display of cosmic art, a reminder of the power and scale of the universe. Yet amidst this chaos, pockets of calm persist. Solar systems, perhaps even life-bearing ones, continue their journey, resilient against the backdrop of galactic upheaval. The collision between the Milky Way and Andromeda is a cosmic inevitability billions of years in the making. Stars may mostly survive, planets might drift into new orbits, and a new elliptical galaxy will rise from the remnants of two spirals. It's a story of destruction and creation, chaos and beauty, reminding us that the universe is in constant motion, reshaping itself on scales far beyond human comprehension. Ultimately, while humanity may never witness this event firsthand, understanding it gives us a glimpse into the grand, intricate dance of galaxies and into the long-term fate of our own cosmic home. If you thought this galactic collision was mind-blowing, wait until you see what would happen if a supermassive black hole devoured the Milky Way. Click here to find out.